All right, welcome everybody. This is 5.1. This unit we'll be talking about point slope form of a linear equation. Our last unit we focused on y equals mx plus b. That's the slope intercept form. All right. So let's just do a quick review. So what is a linear equation? All right. It is a straight line. You could say that there's just one variable and it has no exponents. Those would all be good explanations of what a linear equation is. All right. In Unit 4, we focused on slope-intercept form of a linear equation. This was y equals mx plus b. So what are two things that you need in order to write a linear equation in slope-intercept form? Well, these are the two things we would need, is what m is and what b is. And just a reminder that m is the slope, so we need to have the slope, and b is our y-intercept. So to make a linear equation, or write a linear equation in slope-intercept form, those are the two things that we would need. So let's do a quick review. Write the slope-intercept form of an equation that has the following slope and y-intercept. So looking at A, slope is 2, and the intercept, the y-intercept is 0, -4. So again, this would be our B, and this would be our M. We'll write that into our equation, y equals mx plus b, which would be a -4. So that would be our equation in slope-intercept form. Give B a try. We could do the same. So y equals our slope, which is -1/3, x plus b, and b here is 2, so plus 2. Right, so this is a quick review on how we did the y-intercept, or the slope-intercept form last unit. So what if we are given a slope and a point that is not the y-intercept? So these are y-intercepts, meaning x is 0. So if we had like something like this, where we would have x and y, our x value is 0, so it's going to be on this y-axis. And here for this one, it's -4, so this would be our point would be right here. Okay, but what if we have a point that's not on the y-axis? What if they don't give us the y-intercept? All right, so how we'd do this is we would come up with our equation. Well, y is equal to mx plus b, okay? And they tell us what m is, so let's put that in. We'll get y is equal to -5x plus b, but we don't know what b is, all right? But since we have this point, this could be like our x and this could be our y, we can substitute those into our equation and we can solve for b. So -2 is equal to -5 times 3. That comes from here. And then we'll do plus b, and we can just solve for b and find what our y-intercept is. So here, multiply that together, that gives us a -15 plus b. On the other side, a -2. So we just need to add 15 to both sides. And we would get b is equal to 13. Okay? So now we found b, we could come up with our equation, and we could say, well, y is equal to m, which is -5, x plus b, that's plus 13, and we could come up with our equation that way. All right, so we'll probably not do number or letter b, we'll skip that for later, but one thing, since this is in slope-intercept form, and we're talking about point-slope form, so what if there was like some sort of equation or form that was where all they asked for was the slope and some point? Okay, hint, that is the point-slope form. Okay, so what we just did will work, and there's nothing wrong with that. If you were to do that, you'd still get an equation that would be correct. that would go through that point and has that slope. But this form is easier if you're given a point and the slope. Thus the name point-slope form. Okay, where y1 and y2, okay, this is your point x1 comma y1, and then this would be your slope for your point slope. Okay, so let's use that form and write an equation in point slope form. Okay, so here they have the slope and we have a point. One thing we need to notice is that when we have like y minus y1, these are subtraction. So when you plug those in, it's going to be kind of like the opposite of what you would think. So for example, if we're going to do y minus y1, well, y1 is, we could label that x1 and y1. y1 is negative, so that would be like y minus a negative 2. Okay? Or perhaps just an easier way to say is that when you plug in these values, your signs are going to swap. So here we're going to get a positive 2, and then we have our slope, which is a negative 5, and then we do x minus x1. Well, x1 is 3, so we'll do a minus 3. You can kind of look at the form and have it memorized that way and think that, oh, these signs will change when you put them in. Or another way is you could just think about whenever you plug those in for the x1 and y1, it's going to change their sign. Okay, so here's another example. Let's give this a try. So y, and then this will label these x1 and y1. So y minus y1, which will give us 4, negative 4. So again, that kind of changed that sign, is equal to our slope, which is 2, and then we'll do x minus x1. So x minus x1, which will end up giving us a positive 2, plus 2. Right? So pause and see if you can do C and D by yourself. So here we'll do y minus y1. Here's our y1, our x1. Make sure you do it in order. This is alphabetically, x goes first, then y. So x comma y. Okay, so we'll do y minus a negative 6, because it's a positive 6, is equal to our slope. And then we'll do x minus x1, which will give us a negative 8. Okay, hopefully you got that. And then here's another example. So y minus 6 is equal to 2/3 of x minus 6. All right, so hopefully you're good with that, just plugging it into the formula. Okay, we'll also do another type of problems where we're going to try and find a line that goes through a point that is either parallel or perpendicular to another line. Okay, so if parallel lines have the same slope, okay, so for example, if this was a line, a parallel line would have the same slope, although that wasn't super, that's better, okay, so parallel lines never touch, they have the exact same slope. Okay, so for example, if we want to find an equation for this point that goes through this point and is parallel to this line, okay, our slope, our parallel slope, would be 4. Okay, it uses the exact same slope. It just needs to go through this point. So we would do, this could be our x1 and our y1. So we'll do y minus a negative 7, that will give us a positive 7, is equal to our slope, which here is 4, our parallel slope. Okay, and then we'll do x minus x1, which will give us x minus 1. And that would be a line that is parallel to this equation and goes through this point. All right, give B a try. All right, this is a little different, I guess, so maybe you might just want to practice with your homework. Okay, so here is our point, x1 and y1. And our slope, so again, if this was an equation, this would be y equals mx plus b. Well, there's no x in this equation, so that means that the 8 must be the b, and m must be 0. Okay, so the slope is 0. Okay, so our parallel slope, I'll do this like it's a parallel, our slope is 0. So now we'll use our point, so we'll do y minus y1 is equal to our slope, which is 0, and then we'll do x minus a negative 5. That will give us a positive 5. All right. But 0 times anything is just 0. So our equation will just be y minus 12 is equal to 0. Okay? And we don't need to like solve for y or anything. We want it to be in point slope form. So once you plug it into that form, it's set and you don't need to solve or move things around. All right? The slopes of a perpendicular line are negative reciprocals. Gosh, it took me a second. Negative reciprocals. Okay? So negative, I think you're good with negative, right? So if something is positive and we want to find its perpendicular slope, then we will want to change its sign. The slope will now become negative. Or if the slope was already negative, we'll make it be positive. Reciprocals are like where you flip, okay? So we change the sign and we flip the fraction. So for example, if we want to find something that's a slope that is perpendicular, that's what perp is standing for, is perpendicular. A perpendicular slope to this line, okay? So the perpendicular slope, we would change its sign. Now it will be a negative, and then we will flip the fraction. So this one doesn't have it written as a fraction, but you can always divide something by 1, and then it's a fraction. So we'll just change its sign, and we will flip the fraction. So negative 1/3 would be our perpendicular slope. All right, so now let's plug in our point and our slope into point slope form. So y minus, let's label this again, x1 and y1. So y minus y1, and that will give us y minus a negative 2, give us a positive 2, is equal to negative 1/3, and then we'll do x minus x1, so minus 2. Okay. One thing that's kind of cool about the point slope form is it's basically the same as the equation when we use to find slope. So that's like y2 minus y1 over x2 minus x1. Okay, all they do differently is they take this and they multiply both sides by x minus x1 on both sides, and then that gives us point slope form. Okay, it's just they just take the x2 and y2 and they just call it x. So they just get rid of that. Oops, let me do that. Get rid of that 2. Okay, that canceled, and that's what we end up getting is the point slope form. So it's, if you forget the form, but you remember the formula to come up with slope, you could kind of derive it that way, which is kind of cool. All right, anyways, I got distracted. All right, so here's another example. We want to find a perpendicular slope. So this slope is x equals negative 1. And let's just look at that really quick. So again, if it's x equals negative 1, and this is negative 1, that gives us a vertical line, which has a slope of undefined. Okay, so we want to find a perpendicular slope. So that would be a slope that was like this. This would be the perpendicular slope would be equal to 0, a 0 slope. All right, so our perpendicular slope here would be 0. All right, so now we'll plug everything in. We'll do y minus y1 is equal to our perpendicular slope would be 0 times x minus x1, which would be minus 8. This is very similar to what we did before. This whole thing would be 0, so we'd get y minus 3 is equal to 0. Okay, but most of your problems will be like these A's, 3A and 4A. All right, last but not least is 2 points. You've done this before. We did this in our last unit, and I feel like a lot of you did really good with that. So if we want to write an equation in point-slope form, but all they give you is 2 points, is we would need to find the slope first. Okay, so if we can find the slope, then we can use the slope and one of these points to write an equation in point-slope form. So again, I kind of mentioned this just recently. The slope is y2 minus y1 over x2 minus x1. And we'd label these maybe x1 and y1 and x2 and y2. And we would plug that in. We'd get y2, which is 9, minus y1, which is 3, over x2 minus x1, so 4 minus 1. That gives us 6 over 3, or 2. So our slope is 2. This is our slope. And now we would use our point slope. So you can choose which one you want. I would suggest always use the first one. I think that's where the answer key, like if you check the odds, that's what it will use, is the first point. So that's what I will always use. So we'll do y minus y1, and that would be 3, is equal to our slope, which is 2. And then we'll do x minus x1, and we're done. Okay, so give the next one a try. See if you can do it by yourself. So we'd want to find our slope. Again, would label x1, y1, x2, y2, and then we would do y2 minus y1, so negative 1 minus 0, over x2 minus x1, which would be 3. Okay, and then that would give us a negative 1 over 3, or that's it, so negative 1/3. And we'd plug our stuff in, so we'd do like y minus y1, which would be 0, is equal to negative 1/3 x minus x1, which would be 3. Okay, and if we ever have something that's like a plus 0 or a minus 0, we would just leave it out. Because y minus 0 is just y. So we'd get, this is what we'd get. All right. Well, if you have any questions, let me know. I'd love to help you out. Shoot me an email, and we'll see you later.